Hi guys, and welcome back. In today's video we are going to be talking about working with powers with negative bases. And now this is where things get a little bit tricky, because when it comes to powers with negative bases, the brackets play an extremely important role. This is where things get a little nitpicky. So first thing I'll get everyone to do is take out their powers and exponents foldable, and please open up to the second section, powers with positive versus negative bases. So underneath the notes we made yesterday about positive bases, we are now going to add some examples of negative bases. So first thing I'll get you to do is write example 2. Powers with negative bases. Okay, and now I'm going to put down a few examples that we'll take a look at together. And as you are copying these down, guys, make sure you're really careful about copying the brackets the same way that I write them down, because like I've said, it matters. Okay, when it comes to these negative bases, it really matters. So the first one, A, we've got bracket -2, end bracket, all raised up to the exponent 4. Okay, example B, we've got no brackets at all, just -2 exponent 4. C, we've got bracket -4 end bracket, all raised up to the exponent 3. And finally, example D, we have negative bracket -5 end bracket, all raised up to the exponent 6. Alright, so let's jump in to look at how these are different. So first one, A. So in the power, -2, all in brackets, raised to exponent 4, the base is actually -2, because as soon as they're contained in brackets like that, they're unified. The exponent is 4. So the exponent applies to both the 2 and to the negative sign because of these brackets. So when we write this out as repeated multiplication, this whole thing inside the brackets is what gets repeated, because that is our base. So it turns into -2 times -2 times -2 times -2. So our base in the brackets there is repeated 4 times over according to our exponent. So now, when we go to solve this out, not only do we have to multiply the numbers, of course, like usual, but we have to pay close attention to our integer rules with multiplication. So match or mismatch, right? So this first one, -2 times -2, match, so it comes out to +4. Then we've got +4 times -2, mismatch, so it comes out to -8. And then finally, -8 times -2, we're back to a match, which gives us a positive. And then 8 times 2, 16. So our final answer is positive 16. So I just want you to note here that our exponent, I think I want a different color. Our exponent is an even number. And if you have a negative base within brackets like this, raised to an even exponent, a little trick for you, it's always going to come out positive. Because in the end, if it's being repeated an even number of times, you're always going to end on a match, which makes it positive. Okay, so just remember that. That's a really useful little trick. Okay, next example now. B, we've got no brackets here, just -2 exponent 4. So you might think, how is this different than the first one? Well, if there are no brackets, then the base is actually just 2 exponent 4. The negative is not part of the base here because it hasn't been unified with the brackets. So that means that our exponent only applies to what's directly beside it. So it only applies to the 2. So when we write this out, the negative just sits on the outside. It's not a part of the power here. It's just sitting on the outside. So it's still important. You can't just drop it. We keep it there. But when it comes to the repeated multiplication, just the base gets repeated, which in this case is just the 2. 2 times 2 times 2 times 2. So on our answer, because the negative sign was not repeated, we don't have to worry about match or mismatch. That negative just stays there. So our answer is automatically negative. 2 times 2 is 4, times 2 is 8, times 2 is 16. So our final answer is -16. Okay, another way that this could be written is actually with the negative outside of a bracket, 2 raised to the exponent 4 contained inside. So showing that that 4 only applies to the base, which in this case is 2. The negative is just sitting on the outside. So that's the same thing right there. Okay, so next one, which is very similar looking to A, we've got C, -4, contained in brackets, therefore that means it's unified, raised up to the exponent 3. So when we write this as repeated multiplication, this whole thing, -4, that is our base. 3 is our exponent. So our entire base is going to get repeated. So it looks like this. -4 times -4 times -4. So please notice this time, the one difference that we have here compared to A is that our exponent is now an odd number. So I'm wondering if some of you have already figured out what that's going to mean for our answer. So before I say it, let's take a look. -4 times -4. Match +16. +16 times -4, mismatch, negative, and 16 times 4 gives me 64. Okay, so right there, we ended up with a negative. And that's your trick for odd. Okay, as soon as you see you've got your negative and your 4 unified as the entire base, If the exponent that it's all raised up to is odd, that means that your answer will come out negative. So that's a trick to help save you time. Okay, and the reason why is because as soon as your negative base is being multiplied an odd number of times, you're always going to be ending on a mismatch, which means negative. Alrighty guys, so last one here. D. Here's where it gets really strange looking. We've got a negative bracket, -5 raised to the exponent 6. So all we're going to do here is just apply the rules from above. So the negative outside of the brackets, it does not apply. It's not unified with the rest of this. It's not part of the base. Whereas the -5 inside the brackets, those are now unified. That is now the base, this -5 here. So when we write it out as repeated multiplication, the negative on the outside stays outside. It does not repeat. The one on the inside that is part of the base does repeat. So we end up with -5. I'm going to double up on my brackets here just to show that that extra negative is sitting on the outside. So we've got, sorry guys, oh sorry about that, -5 times -5 times -5 times -5, 1, 2, 3, 4 times -5 times -5. 1, 2, 3, 4, 5, 6. So 6 negatives being repeated. So I know on the inside here it's going to come out positive. However, we also have this negative sitting on the outskirts, which will automatically apply to our answer. So what that means is that my final answer will be negative. So for this one, I'm actually just going to pull out my calculator. And I'm going to just enter this in. 5 exponent 6. And there's my number value. So it comes out to -15,625. That is my final answer there. So if this had been an exponent 5 instead, a negative bracket -5 to exponent 5, well that would mean that what's inside the brackets here, the base that's actually getting repeated, would come out negative plus the negative on the outside. So we would end up with a double negative, which of course would then turn into a match positive. So in this case, because we were positive inside here and the negative on the outside applied, our final answer was negative. Now the last thing I want to mention before I close out this video is that for all of these negative bases, you can actually have your calculator do all of the work for you. However, you have to make sure that you're very careful how you enter it in. If you enter it in wrong, your calculator is going to give you the wrong answer. So you have to enter it exactly how the question gives it to you. So in this first one, where the brackets are around both the negative and the 2, unifying it as my base, I have to enter it that way. So I go bracket, -2, and bracket, all raised up to the exponent 4, equals, and you'll see I get the same answer. See, +16 right there, +16 right there. Whereas let's say I was trying to get that and I didn't bother putting the brackets, I just went, okay, -2, exponent 4, watch what happens. I end up with the wrong answer. okay, because it wasn't a negative. It came out as a positive because I multiplied that -2 by itself an even number of times. But if I don't put the brackets in there, then my calculator reads it as b, where the negative is not part of the base. That's what I've told it. So you can see it gave me -16. Well, that was my answer for b. Okay, let's do the last one. So if I wanted to make the calculator do this funny one for me, let's type it exactly as it's written. Negative bracket -5 end bracket, all raised up to the exponent 6 equals, perfect. See, just like I wrote down there, -15,625. So you can make your calculator do this for you, but you have to make sure that you are entering it exactly as it is written. Okay, because the calculator follows the same rules that we just went through in this lesson. Alright guys, so that's it for negative basis. Once again, if you have any questions, please feel free to email me. And thank you so much for watching. See you all again soon. Bye.